4th of April 2024. 240424. Good number. All right, so today on the agenda, first of all, Pili, are you recording already? Awesome, thank you. So on the agenda, we'll do the Launchpad development since last LOH, Firehose intro/recap, and then we'll do a Helm chart demo for one of the components of Firehose with some open questions. So since last LOH, we have had stable releases of Cello charts, stable releases of monitoring, storage, and Cello. And we have done some refactoring on Launchpad Starter. So this is refactoring. I'll go through those very shortly. And we have also updated some of our docs. So here we have, as promised, finalized the Postgres high availability guide to include pretty much every single one of the content that we've covered in the last LOH. We've implemented the Launchpad Starter changes into docs, and we've upgraded the quick start guide with Arbitrum Sepolia and Graph Arbitrum instructions instead of Graph Girly and It Girly. So I'll just quickly come out of this. So if we, so you have a link already. Thank you, Chris, for posting the link for the Postgres high availability. And then on the quick start, you will see that there's been a lot of changes here, and there's a graph indexer using Arbitrum Sepolia and deploying with Arbitrum Sepolia. And then on the Launchpad Starter, this is biggest change. So in the past, you only had one sample Helm file from which you would get started with Launchpad that contained basically all of your different namespaces, the reference, and then all of the values for each release under that namespace. Since we've been using this pattern for a while, over time, it has grown. So this one file that you start with becomes hundreds and hundreds of lines of code, and it's really unreadable. So instead, we've adopted a new pattern, which is the pattern we are using internally. And what this, how this looks like is your sample Helm file. Instead of having all of the different namespaces into one file, it is split by namespace. So you have a Helm file for storage, one for sealed secrets, and so on. And whatever namespace you'd be using, you would add a path to it, like so. So that's the big change on sample Helm file. Then we have added a helmfile.common.yaml, which allows you to set up some defaults so that you don't have to define them in every single one of the Helm files that you're using for each namespace. So for example, your cube version is something that you need to set into each one of these Helm files. But instead of doing so, you're just inheriting from the helmfile.common. So once you make that change, you don't have to apply it to each file. And then, as mentioned, now each namespace has its own file so that you have space to put the values under, and it's a lot more readable, and it's just been a much better pattern for us. But yeah, this is the biggest change on Launchpad Starter. And then on Launchpad namespaces, we have renamed the Arbitrum1 namespace from Arbitrum1 to Arbitrum, so that we can split into two flavors. So one is the equivalent of the mainnet. So Arbitrum1 is the mainnet, and the Arbitrum Sepolia is the testnet. We went back and forth on this approach because there is no standardized way across all of the different blockchains for this kind of naming. So, but in the end, this made sense more. When Arbitrum Geo, I don't know. Maybe Chris knows. Okay. And how is it? Is it hard to run? Like, what have you noticed that? It'd be interesting to know.
No, it's just another Arbitrum orbit chain.
Okay.
So the so if you know how to run Arbitrum1, then you probably can run Arbitrum, the Geo chain from. Well, let me give some context. Right. So Yaniv is working on Geo. The way they're going, it's currently on Polygon. They're going to change it to work on a rollup chain on Arbitrum. So you call it an L3 chain or an Arbitrum orbit chain, whatever you want to call it, something like that. Yaniv's future vision is that as Geo grows, each of the popular spaces will get its own rollup chain. So imagine the future where there's, hundreds of layer 3 chains that need to be run. Anyway, so we started with just a Geo testnet chain to get started.
I see Chris is commenting. It'll be interesting to see when this is coming on our pipeline.
Yeah,
right.
Exactly. Like they all look exactly the same, except they have a different JSON file that initializes
So basically,
the project. Otherwise, they work.
So basically, all we'd have to do is just add the additional flavor, and that makes sense. That should be very straightforward. Okay. In terms of our Helm chart development today, so we decided to start working on the Firehose. And for that, it makes sense to just quickly remind people. For those that don't know, but maybe this is not the right audience. So the components of Firehose. So we have the Firehose enabled blockchain node, which is the instrumented blockchain node. So then we have the reader, which extracts the data from the blockchain node. We have the merger, which receives one node blocks from reader and produces 100 blocks file. We have the relayer, which provides executed block data to other Firehose components. And then finally, we have the gRPC server, which provides the executed block data to other Firehose components. And
can I make one clarification to the first bullet?
Yes, please go ahead.
So it says instrumented blockchain node, which is correct. But you might also have chains where you don't have an instrumented blockchain node, where you're using the tech called the RPC polar. So where you have your normal Arbitrum, or let's say you have a Bitcoin node or whatever you deployed that with your other Helm charts, and then Firehose is just making RPC calls to the node you already have deployed. So you don't have to actually run a node. So Firehose enabled blockchain node, maybe or maybe not, depending on how it works.
Thank you. That will be useful to yeah.
The reader component is the complicated one because it changes by blockchain stack. The rest of them are like basically the same. So, and they will get more and more the same over time where they're not the same already. So, yeah.
Okay, that's good to know. That will definitely impact how everything is set up.
Yeah, exactly.
And then I stole your diagram. Sorry.
Yeah, of course. Feel free.
But yeah, this is all of the components.
Right, before we jump into the diagram, if you go back to the previous slide, just one minor correction. The merger is one node block. Should that say one block file? Or
yeah, it's one block file, really. It's a one block file or a merge block file. Or just merge block or one block. You know, depending on how shortcut you get into in terms of shortcutting things. The other thing we didn't cover here is the substreams, which of course is another big component of Firehose. I don't know if you're doing it later.
And no, because we're only giving context for starting a Helm chart around Firehose, which we won't even be able to finish it all. So we're keeping it to just Firehose components.
That's fine.
So yeah, this is not a session on Firehose. That's your guys' remit. It's just more, by the way, these are the components and this is how they work together, so that then we can take it and do the Helm chart. So this diagram shows how all of the different components sort of talk to each other. So for example, the reader extracts data from the execution node. That data is one second. That data is then changed by the merger. The relayer is what makes the data available to all of the different components. And then Firehose is the endpoint of how that data becomes available. Sorry, that was not the best explanation.
I can maybe give also like a take on the overview of the flow.
Yeah.
So you have. Sorry, Matthew. Do you want to go ahead? I was going to add something.
I was just trying to ask Kriska's question, answer Kriska's question. The relayer handles live data.
Yes. Okay. So you have a Firehose enabled node, or as Matthew mentioned, does not even need to be instrumented if the RPC interface is enough for Firehose to interact with it. But we're going to build a chart for a reader that actually comes in with its own Firehose enabled nodes, yes. And the interface between Firehose and RPC nodes in this circumstance is really not too complicated. It's just parsing the output, the standard output of the nodes, and taking out the information from there. And that's why it will need to be instrumented. It will need to be sending out to std out all the data that Firehose is then going to consume. So the reader reads that data and produces one block files. And the merger's role is to take those one block files and produce 100 block files, which is very literally what they are. It just merges blocks together and compacts them into a single file. The relayer's role is more for high availability, and maybe more important than high availability, for you to have multiple readers, and they get to witness sometimes different forks, right? Or they don't have exactly the same data. And the relayer is kind of an endpoint that gives you a consistent overview that has all the information. So it aggregates information from multiple readers. And it has exactly the same interface as the reader. Like whatever asks to use a relayer could directly use a single reader. You just put a relayer in front of multiple readers, and it does that. Okay, and as Matthew is saying, merger also removes forks. And the Firehose gRPC is just the endpoint users will interact with and aggregates all of this information on the whole system, which can be very distributed and have multiple instances, high availability, and all of that. The search indexer's role is just to, so the 1 block files go to the object store, the merger produces 100 block files, and the search indexer just creates like a table of contents for those 100 block files, so that it's faster to locate in which file is information about a certain block. I think that's all of it.
And then the only thing I would add here is that my understanding is that the best object store to use for when setting up Firehose is Ceph. I don't know if that has changed since, but yeah, that's what the documentation mentions.
Sorry, what's the question?
The recommendation for object storage to use Ceph?
You can use Google Store. You can use local file system if you don't care about high availability. You could use Ceph. You could use Seaweed FS. I think that works. I don't recommend Minio because I had lots of problems trying to get that to work. So there's multiple options for the object store, including local disk.
Okay, thank you for the clarification. Okay, I will hand over to Carlos to do Helm chart demo now. Thank you.
Yes, not so much a demo, more of a live development, because I think was Vince asked for that, but he's not even here, right? But that's fine. Let me try to share my screen. Hopefully this is working. It works. Okay. Good. So what I'm gonna start with is I'm gonna use Elm to actually create a boilerplate of a whole new chart. So if you do something like Helm create and give it a name, it sets up this folder for you with some boilerplate, quite a lot of stuff, really. And we have a chart.yaml, top level file, where you have your metadata for the chart, type application, there's a version, an app version. You have a bunch of templates out of the box. One for deployment, HPA should be horizontal pod autoscaler, another type of resource, an ingress, a service, and a service account. A notes file, and we have here a file helpers.tpl with some macros in it that get used across this default. So this is kind of what you get as the boilerplate for a new chart. And let me just mention that, like, in reality, when we start a new chart, we don't do this. We kind of take one of our existing charts, which already has a lot of patterns that we may want to reuse, and we copy that, and then we change stuff around. But that will be the circumstances in which you already have existing charts with certain patterns you want to keep implementing. It's easier to take that as a starting point. That will not be the case for anyone starting a new chart for the first time, so let's start here. So it gives us the boilerplate for a deployment. And then I also have here a stateful set resource, not templated. This is just like a bunch of values, a whole spec for a stateful set, which is usable for a stateful set for my reader nodes. So I'm going to take this as a reference about what I want to configure this workload. I want to end up with a parameterizable Helm chart that produces me a stateful set like this, and, like a service. I'm not going to need an ingress for this, so I may want to delete this. I will delete this file. I'm not going to use an ingress, and I will go to values, which also comes populated with the stuff the Helm creates by default. I'm also going to delete the ingress section, which will only be useful for that resource, ingress resource, and I'm going to save. And this is like the first change. I'm just going to quickly check the chat. Nothing. Okay. Please feel free to interrupt or raise any questions. Ideally, this will be a very kind of organic and not one-sided development. So let's start by looking at what we have here. Our deployment as those includes here are invoking the macros, which should be defined on helpers. So it calls a Firehose at full name macro. If you go look at our helpers here and we search for full name, it should be defined. Here it is. There's this section here that says define Firehose at full name. That's how you define a macro. It goes from here until this very last end. And why not just a simple value with the name we want? It implements a bit of logic. It does a truncation to 63 characters, and it trims suffixes. And in case people don't specify, or they can specify a name otherwise on values, it's being picked up here. There should be an entry here, or name, it is name override. So it just handles that logic, does this truncation operation to it, which is motivated by the fact that names have a maximum length. And even if Kubernetes does not enforce a maximum length on pod names, it still will invariably enforce you to have DNS names that do not exceed 255 characters, as all of the pods and services are get DNS entries, right? And DNS names get very long. The standard goes a bit like, say, service name, dot namespace, dot SVC, and then the top level cluster domain, which by default is cluster.local. So if you have very length namespace names and release names like pod names, service names, you go overboard on those 255 characters anyway. So there are constraints about the maximum size to these things. And then it implements its logic with conditionals, supporting the overrides, and it ends by printing the end result, which is a string, two strings separated by a knife, slash, what's this called? Release that name, truncating. So this is an example of this type of pattern that comes by default. There will be others, like labels. Let's just take a very quick look at those. Select the labels and labels. And if chart has an app version defined, and your chart does have an app version, 1.15.0 by default, then it's going to label the deployment with that. And then there's the set of labels, which are called selector labels. Here, which are name and instance. Sorry. Okay, so we have this stuff by default. Let me see if there's anything else noteworthy. It's just, okay, just one more example. This images one, I think, is relevant. So I'm also created an image section here on values so that people can change where our image comes from, change the repository, change the tag, which comes empty by default in values, but people could override the tag. And this is very neat, gives you examples of how to template stuff with Helm. If we come here to our spec on our deployment, we see that our container image follows this values image repository, then the column, and then the tag, which if it's not specified in values, uses by default chart.app version. So our app version here would correspond to the image tag, and our version here would correspond to the charts version, which is whatever we choose it to be, how we want to version it on this default pattern. You might This is useful. Does not account for everything, and I'll give you an example of something you may want to change, which is you may want to specify images not with a tag, but with a digest, because you want to pin images to their SHA sum, their checksum, right? You'll have something like, and then an hash. Okay, this is not allowed. You have, okay, just some hash here, right? A bit longer. Now you have a problem, because when you do this, now you can support tags, you can support digests. You have to choose a policy if the user specifies both, which one takes precedence, and you need to implement the logic right here. And the hard part about the logic, or not the hard part, like a gotcha here, is that the format is different actually. If you are using a tag, you use this column, and if you are using a digest, you need to use
What?
an
I'm in a
symbol.
meeting.
I think you left your microphone. Someone left his microphone up.
Yeah, Vince.
Yes. Oh, Vince has a question.
Yeah, I guess I'll like summarize it better and just saying it. So I found in like helming Firehose, like something in your values YAML, like your config template that you want to create from your values YAML. If you wanted it to always, because it's always like the relayer service is always going to get like pointed at the merger and is one of the flags, and using it as like a var, because basically that that service is going to get called relayer whatever, and I suppose you could just use labels like I did and do relayer whatever. But is there a good way to get variables that you've defined in your deployment or service or anything like that into a values YAML?
The values YAML is not templatable.
Yeah, that was a pain point I came across.
Yes. What you'll have to take care of, like the best you can do if you need templating. Yes, you can use Elm file that allows for that. The other example of a pattern is you can have things in their values. Let me go to the values of this file. Okay, you define some placeholder like key here, like something, doesn't matter what it is, and it's a string now, and you actually use templating. You insert a template here. Like you use some like that affinity referring to that one. Maybe you have some hardwired stuff for your config. Maybe it's a toml, and there's some section here. You're just generating something templatable. Now this is a value, so theoretically, like people can override this and change this template, and then you can consume it. And a deployment, you can actually invoke. There's a Helm function called TPL, which allows you to template some string. Okay, so that's like, this is the most I think you can get in terms of have something in values that then gets templated. Does that make sense? Say my values file is a string, but the string is actually a chunk of templating code, right? Like you want this to be parsed by the Helm templating engine. Okay, you can have this on values, but you need to specifically then, before like you use it, you need to say set some variable that you're going to define. I think I need to evoke set here, or maybe not. And then you use the templating function. which is placeholder there. So I'll go like placeholder as an argument, and this is going to. Oh, I should use this here. Okay, this looks right now. So now you have this variable that has that templated string. Does this make sense?
Yeah, but okay, so you're saying var1 and then it's templating it and passing it to the placeholder variable that you set in your values animal. So if you set because that's just setting to the placeholder, how do you set a string to placeholder?
Well,
Or that is the string? I guess I'm a little
so
confused.
like if you have a look at the example that I dropped a couple of links. The first is use of hang on, wait, is that the right? No, I think, sorry, do you know what? I think I sent a bad link. Give me 1 second. Okay. So that second link, that is an example of what Carlos is showing that we use for graph node. So in this case, well, so weird that that didn't take you to the highlighted.
Yeah,
Yeah,
it took me to line 239.
yeah, that's where it should have.
Okay.
Cool. Yeah, and then what Carlos has on screen is where we actually like render value and use it. And so like the power of this pattern is that you like as you'll see inside the first link where config template is Carlos, can you try navigating to the first link again? Yeah, basically the values file right at the bottom. Um um so this is in, you know, the values.yaml interface, and we're defining just like a string here that we're evaluating later with the TPL helper. And as you can see, we have full access to Go templating as well as the values like object inside of this string. And so, you know, you can specify a set of sensible defaults, but the user can basically override that template to consume the values in a completely different way, right? So they could like append to it or even like extend the chart in some sense, right? Because use they can use values in the template that they're overriding that they also specify in the values.yaml. Does that make sense?
Yes, but I am gonna have to just play with it, just to fully wrap it in my brain. But I think I have a good idea of what you're saying now.
Yeah, that's basically it. You can have Elm values that are strings, and those strings can contain templating, but then you just have to pass it through that TPL function to evaluate them, to render them at templating time. It's a bit more clunky, less direct. But if you're templating as hooks, like to use other, like not hooks, but like references, other keywords that users can use to impact how it's going to template. Say you have like some extra parameters here, like a variable. This template here with the star and like connection, pull size, weight, and then you have here like another line that will just going to invoke some Helm values parameter, like star values extra parameters. Then users will have an option to just add some parameters to that key, and it will, like show up on this templating. Like, so you have the full power of templating here, and you can make it customizable by users on more user-friendly ways than to have to override this whole key, like just copy paste this and then make changes to it. But that's, like the more you build into this, the more work it is, right, to build it. The more features you want, or the more complexity it will end up with. But yes, values otherwise are not templated. They do not run through the templating file. But they can contain strings with short templating, and you can manually invoke the function on them to template them.
Yeah, because that was, I guess, the main thing was reproducibility. Because like with Firehose, especially, like you're gonna have a bunch of them, and I guess you could call them all the same thing and put them in different namespaces. But it is nice to have the pods like have the network and the chain version, because if there's a like a major reorg, you'll have version 1, version 2, version 3. So having those things in the naming scheme is good, because then you can parallelize, like, okay, I'm going to keep version 2 running while I run version 3. Version 3 is good now. I can shut down version 2. So having these things named with versioning and networks makes it a lot more reproducible, especially when you're just like glancing at it and saying, oh, okay. So getting those things more easy for a user, because when I'm trying to build Firehose right now, basically I'm trying to make it as easy as possible for users to like be able to reproduce this without changing too many things, where the values are taking care of the manual work, I guess, of like, oh, this is, besides changing like the version.
Yes. Okay. I'm gonna just finish this image part here, because I'm gonna use this as an example to point you guys to something which I think is a good reference. So Bitnami has a lot of charts, with a lot of maturity. You can find it GitHub Bitnami charts. You go to the Bitnami folder, and there's like a ton of charts there. But in particular, I have a common library chart, which has a bunch of functionality. And there's an image templating here, which actually handles this. It handles the logic between using a separator, which is a column, or an at symbol because you want to use a digest. It's a good reference. I would advise people to also explore, as they're developing charts, patterns to be found here. So yes, take that as a reference, Bitnami. If I wanted to use this, I could just copy it to my helpers. Yes, go ahead.
Yeah, no, sorry, Carlos, didn't mean to cut you off there. I just wanted to share that the way, because it sounded like, Vince, part of what you were after there was just like standardized, consistent naming that kind of supports a diversity of networks and versions and so on.
Yeah, without much input or
Yeah.
editing, basically. Yeah.
Yeah. So I would say the way that we've typically approached that is, well, first of all, as you pointed out, there's like Kubernetes namespacing as like the first, kind of foundational primitive to separate workloads. But beyond that, we typically approach that in like basically in the Helm release name. Um, so, any details like what network it is. So for example, like when we deploy something like the Aragon chart, the Aragon chart, doesn't really, like, obviously you can configure the chart to specify a specific chain ID and, like, generally configure Aragon to be on X network instead of Y network. But otherwise the Aragon chart doesn't like put anything like the network name in the full name of the pod or anything like that. We handle that kind of outside of the chart by assigning that release of the Aragon chart a name that includes details like, what network is it, and potentially information like what version of the Firehose it is, and things like that. So yeah, I would say, yeah, we use the release name to approach that problem. And then I know you guys aren't using Helm file, but with Launchpad namespaces that has the ability to kind of template out these declarative Helm releases, that's kind of how we would handle automation and consistency from a release naming perspective, because we would be able to use the templating in the Launchpad namespace to consistently and automatically generate the names of the Helm chart releases based on configuration that is passed to the namespace, like the flavor or the version or whatever.
Yes, I will also just add one very small piece of advice. If you tackle that problem, I advise you to also add those parameters, like the network, whatever metadata about that deployment, add labels to the services, to the stateful sets. You will want those later on.
Yeah, because the main thing too is like it's not just within, it's not just like, oh, because Firehose Ethereum deals with a load of EVM chains, and so it's not just like the Firehose Ethereum release, Ethereum mainnet, Firehose Ethereum, Ethereum's Polia, or whatever. It's also like you'll be running stuff within the same namespace, and it's up to the provider. Like Matthew was talking about, we're on version V6 as of Monday, so you'll be running basically the same primitive of namespace, but running them in parallel until the other one is ready to deprecate. So you'll be running like the same thing, just with different flags, basically, and naming, so what's what. Especially if you're using local storage, same thing, but especially when you're using like S3 storage for all the flat files and merge blocks and stuff. It's like really important that you're able to achieve that. I'm going to run this twice, basically, in separate instances. Basically be able to run it in separate instances in parallel.
Yes.
And then there's also and then there's also the problem of, if you have a hole in your blocks or something like that, you just need to run like two of the components, the reader and the merger, to basically take those things, put them together, smush them together, so you can then like have that fixed merge blocks, that hole, and rebuild it in another thing.
Yes, I guess what you really need, I mean, like what it comes down to is you need to have a scheme of naming.
Yes.
Because I don't think you'll be able to, from what I understand of what your needs are, you like labels are only more meaningful inside the cluster's context, not at runtime, not at Helm templating. So you probably do need to leverage naming. So you need a convention, you need like a scheme to include all the info you want to have, and then you need to be very consistent across the boards. Like then, if you can assume the names follow that pattern, you can extract things from them, and you can also template them, right? You can count on them, like you know what the endpoints will be like, because the names are predictable and have the information that differentiates. If it's V6, V5, then Helm chart could have a parameter for that version that can be 6 or 5 or 4, and wherever it names things, it's going to like leverage that value and name them accordingly.
Yeah, that's where I've gotten close to achieving. I haven't done the versioning yet, but yeah, the one thing I was like, how do I approach this was the values, because like if you just put, for the or I'll have to just relabel the services, like relayer version, whatever. Because if you're running them in parallel, you can't have a relayer label and a relayer label. It won't know what to go to in that namespace. So it's just
No, like, but you have control over. Oh, you're talking about the relayer perspective? From the relayer
just
perspective?
basically just like the other pods, like let's say you have the merger that needs to talk to the relayer, and you already have a relayer service that's named, Firehose Ethereum relayer mainnet, from your labels and everything from your templating. But now I'm realizing I also need the versioning in the labels as well, because if it calls
Yeah.
deterministically
Yes.
on that service, it needs the versioning as well.
Yes. Your selector labels, which is not this. Yes, selector here. Like this part on your deployment should include a lot of stuff. Basically,
Yes. Yes.
you need to
Sorry,
put
Sarah.
all of that in here. Yes, go ahead.
I know this is a good time to interrupt, but Marcus needs to make an announcement, and he can't stay for any longer. Can we just pause for a couple of minutes for Marcus to give us an update about the upgrade?
Yes, I'll stop sharing.
Okay. Go ahead, Marcus.
Thank you so much. This won't take more than just a minute or two. I just want to reach out and say, first off, hi, everybody. Thanks for having me on. And then also, we are actively in the upgrade window right now. This is something that the Graph has been planning for many, many, many months, for years. And we are doing our very best to get the word out. So if anyone here knows subgraph developers, knows dApps, knows any team that are actively building subgraphs, it would be right now a very good time to reach out to them, either through DMs, either through social media, phone calls, texts, whatever you got, and see if they have any hosted service subgraphs. And if they are able to, please upgrade to the Graph network. And so the cutoff time is and date is June 12th. So it's coming up in 49 days right now. So we are in the window right now. And if there's anyone that you could reach out to, we're all hands on deck in terms of the core development kind of teams. We're all asking for everybody to do their very best. So yes, smoke signals, carrier pigeons, message in a bottle. Let's see. Let's get the word out. All hands on deck. If you're in the Graph ecosystem, let's all see if we could reach out to someone and spend a little bit of time every week to getting this word out and upgrade. So thank you for your time. If there's any, TikTok, you bet. I'm actually going to be recording a TikTok this week and putting it out there. So I'm doing my very best to not look too old as I create a TikTok with all those youngins on there. So any other ideas, any other questions, comments, I can stick around here. I do have a hard stop on the hour, but if there's no questions, I could pass it back to you guys. Okay, I'm assuming by the quiet there are no questions. I see Vince, you're typing. That might be a question. Yeah, it really is. Exactly. So, yes, everyone, all hands on deck. Let's do this. So that's all. No questions. I'll pass the mic back. Thank you for your time, everybody.
Thank you, Marcus. I'm going to try to share my screen again, which hopefully works. Okay. I was saying, yes, your selector match label is going to include a lot of stuff. There was a few things I wanted to go over in this session, and by looking at the time, like it feels like time went by really, really fast. We almost didn't do anything. I mean, we literally almost didn't do anything in the chart. So I'm going to very quickly focus on one which I think brings the most value in the immediate, especially for maybe even for you, Vince, and Pinex in general, but for everyone, I think. which is the subject of configuration management, which is hard. So I had this manifest here, and I was planning on starting to transforming this into deploying something like that, but I guess we won't get much further, a lot further in the few minutes remaining. But this particular workload has an interesting thing. It has environmental variables like this one, reader node arguments, which is a single string which contains a ton of flags, right? So I will go to my deployment, which I still haven't changed into a stateful set, but invest into a stateful set because I'm going to want a stateful set. Either way, deployment of stateful set, it should have a name section on its templating spec. I have a container here, name, image, parts, resources, and it could also have envars. And then I'm going to add an envar here, which is this one with that value. Okay, so now this is hardwires, right? And we don't want that. The naive step next would be to come to values and to as a name section. And then people can add keys here, or we can have some predefined default ones. In this case, I'll have this one here with this value. And then people can customize that key, and instead of having a hardwired one here, I could have some templating that was to a range with key value. So they're just gonna go over all the keys and values on the data values.m, and I will replace this with it's going to be key column value, and then I need
think it's
an
actually
answer.
I think it's an array. Like the env is not an object; it's an array. And then there's a name key, which is the name, and then a value key, I think.
Oh yes, that may be right. That does seem right. So name will be the key, and then value will be my value. But like the general pattern, kind of like this, right? And I will need to change my. I will need to change my. Thank you, Chris. My values. This is not though the point I want is to cover. So my env here would be an array. Now, arrays, for one, like the first issue here is that we have a lot of parameters here, and this is really terrible configuration user experience, because imagine a user wants to change any of them. Then he needs to copy this whole thing to override it all and just change whatever he needs to change, he wants to change, right? Then there's a second set of issues, which come by using lists like this one, which is an array. The set of issues there is that lists do not merge well. Like YAML merging, when you have two YAML files, if you want to overlay values to change something, say change your default, with keys it's easier to merge that, like the user provided values that get layered on top of the default ones. Or on Launchpad namespaces, we use a lot of layering. Arrays work really bad for that because there's no way to remove existing keys, there's no way to override existing keys. You would like to provide defaults for these parameters, but also an easy way for users to override them. And the best user experience on that would be to have some kind of a config section where you declare a bunch of at least everything you're going to use as default to make it easily overridable. You will declare a bunch of parameters, say, oh, it's RPC, vhosts, and then a default, which is.
I'm not sure if you actually want to do that for this fire reader node arguments, because every different Firehose has different kinds of arguments. Like if you're using Bitcoin, it works this way. If you're using Tendermint, it works that way. If you're using Ethereum, it works that way. If you're using, the amount of variance for that fire reader node arguments is infinite.
Yes, yes, maybe this is not the good example of you wanting to do this, but it is an example that does happen a lot in terms of the workloads not always they not always have all parameters configurable by independent envars. This is not the first time I saw this type of pattern, right? The use case at least is, I assure you, useful. You're gonna run into this.
I think in this particular case, that would work seamlessly because there is no kind of schema for the config object defined on line 88. And the template will just iterate through the keys in that object and convert them into a list of arguments. So you could throw any set of keys in that object, right? Whatever args were appropriate for the chain, and everything should work seamlessly.
Yeah, that was my, I guess the little config map that I posted. That's kind of how I approached it. Like reader node, the start arg reader node, that'll never change. The flags that will change. And then so I made in my values YAML, I just had config, and you can put any key value pair you want for that config, and it just turns into the config YAML that it runs.
Yes,
basically similar to what you're writing right now.
Yes, except your config, if I recall correctly, is kind of a single string like this, right?
And then it's a bunch of values below that, like whatever values you put below that, it will run.
So a user cannot just change one. You have this as a default, right? And if I want to install your chart, I need to copy paste this and override it all and change what I want changed, right? I can't just change a single parameter. I need to, my values files needs to contain everything you add there as a default, not just the only parameter I want to change, right? And that means, yes.
Couldn't you just edit the values YAML and then it will run, because it's going to run whatever I give the values YAML for that config and put it inside of the config map.
No, I can edit. I think say your chart provides workable defaults, and I just want to change a single thing. Then I still need to have a values of my own that has the whole thing, but just with that parameter changed. And that is easy because you copy paste once, except that now your values, like your personal values file for your own deployment, contains that whole list, which means that you have more stuff to do to maintain it forward. Because imagine there's a new Firehose and the parameters changed, and your chart changed its defaults. Now the user has to recopy everything again, right? He has to keep it in sync with the defaults on his own. While theoretically maybe the single parameter is changing, we'll avoid having to have that all work if only he has the other option to just change that one. Does that make sense?
I don't know. Because are you saying that since I have it in my values YAML by default, that's basically just going to be whatever the user adds, no matter what, those values that I put in config are going to be tacked on no matter what? Because when I do that, I can, because basically in my template that shoots out all those config variables, if I edit a line, or I can delete all of them and put all brand new ones, because it's just if you take the default Firehose config or whatever, or the values YAML, and you change every single one of those flags, like that's what gets put into the config map. So I'm not sure what you mean by like, because the user can change the values YAML to whatever they want and put in there. Like they just edit it. They don't have to like copy and paste anything.
When you say they edit it, like
when you do, like you edit whatever you want to go in that config. Like, let me grab an example here.
let's frame this like some other way. Imagine I don't have your chart at all. Like
Okay.
you have a remote repository. It's public, right? I'm just going to install it from the remote repository. I
Sure.
don't even have a values YAML. I'm going to go right with the default values of the chart. And now I want to change only the cache parameter, and there's like 100 of them.
Mm-hmm.
Now I need to create a values file to use, right?
Mm-hmm. But why
And what I
wouldn't you
put
have the
here,
values YAML?
well, because like I don't need to change the defaults if they're working, if they're good defaults,
Because I guess my plan on it, like, because there's tons of Helm charts where you just run the Helm chart and it works by default. But my plan was more so, since it's so broad and so diverse, especially if you decide, oh, I'm going to use S3 storage, or I'm going to use local storage, or I'm going to do it this way, or I'm going to change these flags, or I'm going to do this, or I'm going to change these ports, or whatever, how you want to do it. Like, my goal is, like, unless you edit it to your specifications, like it'll run on maybe Ethereum Sepolia or something. But because we're gonna put it on Artifact Hub, which does contain the values YAML, and you can just edit those to your heart's desire. I'm not necessarily of
no,
the
no,
mind that it should
I
run by default.
yes, I get that. I get why it doesn't make much sense to you for your use case, but like consider the fact that we're providing Launchpad. That's a goal
Yes.
for us, right?
Yes.
Like that some user can just go with defaults and end up with a working setup. So there's like this consideration about users will maybe change things like the storage class, say that's almost mandatory, like everyone's gonna
Mm-hmm.
have that. But ideally we want to have charts for Launchpads in which the defaults that users are overlaying aren't that big, right? Like the values. And in order to change something like this pattern means that if I want to change a single value, I need to reproduce the whole thing. And from that point onwards, it also means that every time you release a new chart, I need to go check if your defaults changed, because I need to update mine on my end, like my values file, right? Needs to be updated as well. Because there's a new Firehose version, there are new parameters. Even if this cache one, which is the single one that I'm changing, remains the same throughout all of that lifecycle, I will still have the burden of always being worried. Now, if I could assume that you provide a chart that has working defaults, and you are yourself taking care of adjusting the configurations to match new Firehose versions, then, and I'm not overlaying almost anything, then I have a much easier life, right? Things just work for me more easily. So there's value in that. And if you're after that, and now I get that you're not for your use case, but if you are, this is like, I would recommend checking out the pattern on Arbitrum chart, on Launchpad charts, which was what I was going to change, but we're already past time. I'm sorry for that. Like say Arbitrum Nitro in helpers, we have this whole. It's also a use case where you want a list of arguments. We built a list with arguments coming one by one from a config section, which has like keys for each one. There's also the whole question about you using logic to go, like if the user adds an extra argument, but it's already one that existed on the default, to like overwrite it instead of passing it twice to the command line, stuff like that. So we dynamically build the list, and then you can easily template it. Where's my stateful set? There should be a command here. yes, you go through a range of that nitro args list, right? And you stick them there. Or for this case, where you want an env var that's just a big string, you will be just joining the whole list, right? You'll use the join function, and you'll create dynamically that whole list from multiple keys. Yes, I want to touch upon that. Time is up. I mentioned Sprig. Helm also has a bunch of templating functions, good documentation. Those are good to check out. And yes, any questions? I know this was we ended up not doing almost anything. So, would you guys be interested?
Discussion.
Yes, yes, but in terms of chart development, this ended up being very underwhelming. So, are you guys interested in having further sessions where we pick it up from here and advance a bit further? Or are you guys feeling like you have enough of Helm charts?
Give me as much as you can on Helm charts. Download me your brain.
That's
So
fine.
that was let's continue. The other thing I was just going to add here with this config block. Oh, you just went away from it.
Sorry. This config block,
you know, if you notice, like discovery port 30310, this actually needs more templating or whatever to get the actual one that's enabled through the firewall, right?
Yes. Yes.
And the JWT, same thing. It needs to be the one that's shared with Lighthouse, right? So we can't just copy paste this whole thing, because some of that stuff should be managed by internally in the Helm chart in other ways. And the other thing is like the datadir -node datadir, that's automatically substituted by Firehose itself. So Firehose has some magic interpolations as well.
Yes, and the parts are even trickier. It was also something I wanted to touch upon because we have all of these parts on this resource, and then a few of them are the peer-to-peer parts, which require a node part or a host part service type. And those come with different challenges as well. Some workloads require you to pass on the external IP address, and you can't know that. Like, that can't be a valid user input because it doesn't know ahead of time in which node it's going to get scheduled, right? So you need to have a init container to lift that. We have examples of that pattern on Launchpad charts.
Yeah.
And it becomes, it sometimes is challenging to make this all work, especially because the workloads do not all. There are workloads that work in ways which make this easier for us, and there are some that don't. And when they don't, it becomes a pain, and it's not trivial. But there are workable, ugly, like more cleaner or more ugly, but in general, you can find some kind of a workaround. Sometimes it's a bit convoluted though. But yes, like those parts here. If you want to support users to have node parts, peer-to-peer node parts, that they do not specify themselves, they want like the Kubernetes cluster to assign them automatically, instead of them having to manage which ones have been allocated, then you also need to uncover them on runtime. But then you need them to end up on all sorts of places, like command lines, sometimes config files.
That's exactly what I want, because we have existing system that does that. So like when I deploy an Aragon node, the Firehose knows how to peer with the Aragon node, right? So the peer-to-peer runs within the Kubernetes cluster and not have to go out to sync to another node in the world, right? So
yes,
we need this kind of interesting logic.
Yes, I think if we go to, I don't know, Aragon templates and stateful nodes, the stateful setup probably has a peer-to-peer init container.
Yeah, because it needs to figure out all the other peers in the cluster and then add them all, right?
You know, like you see like an example here of how to get the external port, external IP. The external port is actually doing a get services to find out which one got assigned, right? Yeah. And then it sets all of those in envvars. And then your container can have those envvars. It's importing them here. You know, like env init node part. Like the init container creates a file with all of these findings, and then there's an envvar which gets lifted, like gets set from that. They're here. You know, like you have these environmental variables, and like this flag now is using it.
Yep.
So
lots of stuff like that needs to be done here.
Yeah.
So
You could have then, like, if you wanted to change a config file, you would probably be running, before running your workload, some kind of a script that runs sed and changes those parameters. And if you have multiple deployments on the same chart, you need to do this consistently. Like, and just, yes, all of this needs to be built. There's no other way I know of.
I would say a lot of the templating that we're talking about here, like, yeah, like, templating out release names, or like templating out like P2P ports that, have been assigned to a given service, and a lot of that type of stuff we template in the Helm file layer, because it's just kind of not really possible to template it in the Helm layer. So yeah, we approach it, one layer higher.
it's just amazing to me the amount of stuff that you have to write to do something seemingly relatively simple.
You like open a port?
Exactly.
Yeah. I guess
It's
my main
mind-boggling.
Yeah, I guess my main takeaway. So just because obviously we want to work together on this, to make Firehose make it to Launchpad, when you guys are releasing it, it's going to be Firehose Ethereum release, and it's going to be whatever chain, ARBS Polia, and you're going to have a Firehose Ethereum ARB, whatever. Just all the other chains, the same like binary Firehose Ethereum that runs all these EVM chains, but you're going to have a release for every single one. Is that how you're going to approach the releases?
Not a chart release. I imagine what we'll end up with is a small collection of charts that relate to Firehose. It could be that we just land up with a single, well, I should say Firehose Ethereum, right? Which, might be better named Firehose EVM, but one or a small number of charts. And I say one because I don't know if you've noticed in our charts, we have this kind of notion of a component inside a chart.
Yes.
Yeah, so we, it might be that we have a single chart, and kind of the reader and the merger and so on are defined as components. But obviously an alternative pattern would be to put each of those components in its own chart and, compose that way. But yeah, we'll end up with a collection of charts. Then we'll end up with a Launchpad namespace that basically templates, those charts into a set of releases that are pre-configured to kind of speak to one another. So that would include, templating out all of the release names, as well as the configuration options that, would kind
make
of
that specific thing work.
Yeah, and
Yeah.
point the components that. Yeah, go ahead, Carlos.
Yes, I was just going to say, as a simpler than Firehose specific example, we have a Aragon chart, right? And we have like Gnosis and Ethereum both using
Polygon.
Aragon. Yes, and Polygon. But Polygon is not released yet. Like, we have those three namespaces, Polygon, Gnosis, and Ethereum, but we only have a single chart. And sometimes inside the same namespace, we have support for testnets and mainnets.
Okay.
So what Chris was saying, like, namespaces give us a very easy way to provide default sets of values, different default sets of values. So whatever we need to do to parameterize Firehose so that we can support all of that with the same chart is what we will attempt to do. And then we will have that diversity at the namespace layer and not so much in the chart layer, because you can't really provide people with different defaults for the same chart, right?
Yeah. Yeah, that's kind of my goal too, because there's like 4 main ones. There's Firehose Ethereum, Firehose Core, Firehose Bitcoin, Firehose Near, and then everything kind of, and Firehose Arbitrum, and all of those things. Hopefully, all of this goes just to Firehose Core someday. but
I think you're walking some steps further into surrendering into a Helm file.
yeah. Right now, I'm just trying to do Firehose Ethereum because that takes care of a lot of chains in one shot.
Yes. Okay, we're a lot over time. Sorry for that, and for coming so little, but hope you guys had a good time or enjoyed. And so stay tuned.
All right. Thank you so
Any
much.
last questions or anything?
Thanks, everyone.
Thank
See
you.
you next time. Bye.
Bye.